Welcome back to Observability Explained. This is episode 2, and today we're tackling the second pillar, metrics. Last time we talked about logs, the stories your system tells. Now we're moving to the numbers that quietly watch everything you run. And to do that, we're going deep on Prometheus, how it scrapes data, where it stores it, and how you query it to actually understand what's happening. So let's start with the problem itself. Metrics, as we said last time, tell you how much and how many, request rates, CPU, memory, queue depths. But on their own, they're just numbers scattered across machines. You can't SSH into 100 servers and eyeball graphs by hand. And without history, you can't spot a trend creeping up on you. What we really need is one tool that goes out, collects every number on a schedule, keeps the history, and lets us ask questions of it. That tool is Prometheus. So here's Prometheus in a single breath. It's an open source metrics database that reaches out to your services on a schedule, pulls the numbers back, stores them as time series, and lets you query and alert on everything it's collected. 3 ideas to hang on to as we go deeper. It's a time series store at heart. It works by scraping rather than waiting to be pushed to, and you talk to it through a query language called PromQL. Each of those will get its own moment shortly. Let's start with the most fundamental piece, the time series itself. At heart, a metric is just a stream of points, each one a timestamp paired with a value, and Prometheus adds a fresh point every time it scrapes your service. String enough of those together and you get the kind of line you see on the right, a history you can chart, compare, and reason about. And later, labels will let us take a single metric like HTTP requests, total, and slice it into many parallel series, one per route, status code, or instance. So where do those points actually come from? This is the part that surprises people coming from other systems. Prometheus pulls. On a regular interval, usually every 15 seconds, it reaches out over HTTP and gets a metrics endpoint on each target. Your web app, a database exporter, a node exporter on the host. Your application's job is simply to expose the current numbers at that URL. It never pushes anywhere. It just sits there and Prometheus comes knocking. Now, why pull instead of push? The big win is that the server is in charge. It knows its targets, controls the scrape rate, and if a fetch fails, that's an immediate, honest signal the target is down. Push systems flip that around. Each app sends its own metrics out, which is genuinely useful for short-lived batch jobs that finish before anyone could scrape them. Prometheus doesn't ignore that case. There's a push gateway for exactly those situations, but for everything long-running, pull keeps discovery and health checks simple by default. So what does Prometheus actually fetch when it scrapes a target? Just this, plain text, 1 metric per line. Each line has a name, optional labels in curly braces, and a number. Here you can see HTTP requests, a total broken down by method and status. So a single counter becomes many time series, 1 per label combination. The help and type comments tell Prometheus whether it's looking at a counter that only goes up or a gauge like CPU seconds that can move freely. That type comment hints at something bigger. Prometheus really only has 4 metric types to learn. Counters only climb upward, perfect for things like total requests or error counts. Gauges move freely in both directions. Memory usage, queue depth, temperature. Histograms bucket observations so you can compute latency percentiles like P95 or P99 later in PromQL. And summaries do something similar, but pre-compute those percentiles on the client side. In practice, counters and gauges handle most of what you'll write, and histograms show up the moment you care about latency distributions. Now, the real power of these metrics comes from labels. Key value pairs you attach to give each measurement extra dimensions like method, status, endpoint, or region. Every unique combination of labels becomes its own time series under the hood, which is what lets a single metric name like HTTP requests total split cleanly into successes versus errors at query time. The catch is cardinality. Labels with unbounded values, like user IDs or request IDs, multiply your series count fast and can wreck your storage. Stick to low cardinality, meaningful dimensions. Once your data is in, you need a way to ask questions of it. And that's where PromQL comes in. The workhorse's rate, which takes an ever-climbing counter like HTTP requests total and turns it into a per-second number over a window. Here, the last 5 minutes. From there, you can compose. Some by status groups that rate into successes and errors. Histogram quantile pulls a P95 of latency out of a histogram, and a simple ratio gives you an error percentage. You're not querying rows. You're computing new time series from existing ones. Now that we've seen how to query the data, let's zoom out and look at the full stack around it. Exporters sit next to things that don't speak Prometheus natively, databases, the operating system, and expose a metrics endpoint on their behalf. The Prometheus server does the heavy lifting, scraping those targets, storing the series, and running your PromQL. Alert Manager takes the alerts Prometheus fires and routes them to Slack, email, or a pager, and Grafana sits on top, querying Prometheus to draw the dashboards you actually look at. 4 pieces, one classic open source trio, plus the exporters that feed it. Alert Manager is one of those 4 pieces, so let's see how an alert actually gets born. As you write a small rule, a PromQL expression, here the error rate over 5 minutes being above 5%, and a duration. If that condition stays true for the whole window, Prometheus fires. 2 habits worth keeping. Alert on symptoms users feel, not every twitchy metric, and use that for clause, so a brief spike doesn't page you at 3 in the morning. Before we move on, let's clear up 3 myths that trip people up constantly. First, Prometheus doesn't store logs. It's metrics only, so pair it with something like Loki or ELK, and a tracer for traces. Second, don't label everything. High cardinality labels like user IDs or request IDs explode into millions of series and eat memory alive. And third, it's not a long-term warehouse. Local storage is deliberately short-term, so for real retention, you remote write into Thanos, Mimir, or Cortex. That naturally leads into a short field guide for doing metrics well. On the do side, keep label cardinality low, always wrap counters and rate. Before you reason about them, alert on user-facing symptoms rather than internal noise, and lean on existing exporters instead of reinventing them. On the avoid side, don't shove IDs or emails into labels. Don't alert on raw counter values. Don't treat Prometheus as long-term storage. And please don't expose secrets on your metrics endpoint. With those habits in mind, it's worth zooming out to see where Prometheus actually sits in the wider toolchain. Prometheus itself is the scraper and time series database, with Node Exporter feeding it host-level metrics. Grafana layers dashboards on top, while Alert Manager handles routing and deduping the alerts Prometheus fires. And when you outgrow a single box, Thanos or Mimir give you long-term storage and scale, with open telemetry sitting alongside as the vendor-neutral way to get metrics in. So before we move on, let's pull the threads together. Prometheus is a time series database that pulls metrics by scraping a metrics endpoint on a schedule. You've got 4 core types to reach for: counter, gauge, histogram, and summary. And labels are what turn a single metric into many dimensions you can slice by. PromQL is how you ask questions of that data, while Alert Manager and Grafana sit on top for notifications and dashboards. And that puts us right at the middle pillar of the bigger picture. Think of observability as a workflow. Metrics, as what we've been digging into, are how you spot the problem and fire the alert. Traces, which we'll cover next, help you locate the slow service. Logs give you the detailed error to read, and Grafana ties it all together on a dashboard. Metrics come first because they're cheap, always on, and the trigger for everything else. If you want to keep going beyond this episode, there are 2 natural paths. The Observability Explained track walks through the full picture: logs, metrics, traces, dashboards, alerting, and SLOs in the same paced style as this series. And if your focus is actually running systems day to day, the production track pairs metrics and alerting with the hardening you need to operate safely at scale. Both leave over at dargslan.com/courses whenever you're ready. Before we wrap, I'm curious. What are you actually using to watch your systems? Prometheus, Datadog, something homegrown, or honestly still flying a little blind? And if you've ever been burned by a label that exploded your cardinality overnight, I want to hear that story too. Drop it in the comments. Those are the threads that often turn into the next video. And that's Metrics in the Box. Next time we pick up the other big thread of observability on traces and see how they fill in the gaps that metrics alone can't show you. If you want to catch that one when it lands, hit subscribe, and you'll find the rest of the series and write-ups over at dargslan.com. Thanks for watching. I'll see you in part 3.